Scientists working on the South Island's Alpine fault have discovered a 50-kilometre section is prone to small earthquakes that last up to half an hour. It's a phenomenon apparently only seen once before on the San Andreas fault in the northwest United States. We aren't yet sure what it might mean, but the study was led by Tim Stern, Professor of Geophysics at Victoria University, and I hope he can tell me a bit more about him. He's here now. Good morning.
Good morning, Jeff.
So, a half-hour earthquake, it sounds quite intriguing.
Well, this slow slip or tremor that we found is thought to result from slip-on faults that are so slow, they move so slowly that it's seen as a sharp, it's not seen as a sharp, discrete earthquake like a regular one, but it sort of rumbles along, and the tremor occurs over periods of perhaps 5 minutes, 30 minutes, even weeks or years.
So you'd only find it if you got special equipment, dug down into the earth?
Yes, what we did was we identified the central section of the Alpine fault from really from the Karangaroo River in the south up to Wataroa, where we noted that there was a lack of earthquakes, and we went in there with a very high resolution array of equipment. We put 11 instruments in, and we put them in boreholes rather than just on the surface of the earth, and that allowed us to record very small earthquakes without being bothered by wind and rain and other effects which surface instruments would
So we're
have.
basically finding the fault is moving all the time?
Well, it's over the two-year period of data that we've looked at so far, we find something like 12 days of that period. There was this energetic period when we had this slow slip events, and each event lasted up to 30 minutes long.
Is this part of plate tectonics? Is that what's driving it?
Yes, so this is in the very deep part of the fault zone. So we have the regular earthquakes which occur in the top 10 kilometres, and they're quite small earthquakes, and that's what we can detect with the GeoNet network at the surface. But what we detected with these events, which we located between 20 and 45 kilometres deep, and you would not have detected these at all. They would be equivalent to about a magnitude 1 earthquake, which is just not detectable by the national network.
So if we found them, and they're also in the San Andreas fault, does that indicate that the same sort of thing could be going on all around the world? We just haven't measured it before?
That's possible. These events have been found in subduction zones in Japan, and in fact they were only just found they were first reported in 2002 from Japan, and then from the Vancouver-Seattle area shortly thereafter, and then the first strike slip fault in a continental area was the San Andreas, where it's found, and now we found it in the Alpine fault in New Zealand. Yes.
How much movement is involved in this?
Very small. It's very small amounts. I should emphasise that this is no substitute for the absolute plate motion. So we're just taking up very small amounts of movement. But the fact that we have found these down at that depth is we think very significant.
Is there a fair amount of energy involved, presumably?
There's a fair amount of energy, but nothing compared to the large earthquakes. So it's just very small movements. The thought from our colleagues who work in the US is that this tremor events may be actually leading to a stress build-up, which could lead to a larger event, and that's one view. And then there's the opposing view that in fact these are like the tremor acts like a stress relief. So we don't really know, but it's important. We do know now that we have discovered these events down in this part of Westland, and we think it's very important now we go back and monitor them with a bigger array.
And one day we'll know whether there are whistles saying something's happening or whistles saying something has happened.
Exactly. We'd be in a much better position to do that. So we think it's an important discovery, and it links in with this work in California and in Japan, and we really want to carry it further on now.
Fascinating stuff. Thank you for joining us today. It's Professor Tim Stern from Victoria University.